You're listening to ChainLeak, the crypto news podcast with your host, Joshuwa Roomsberg. Follow and subscribe today.
Welcome to the ChainLeak podcast. I'm your host, Joshuwa Roomsberg. Today's episode is about biotech In-Fluence. Today's guest, Tom Trowbridge. Welcome to the show, brother.
Hey, man. Thank you for having me, Josh. Appreciate it.
All right. So Fluence is a decentralized computing platform.
Correct. And it's a lot of words, and I can make it even more words, but
Okay.
but effectively what that means is we call it cloudless to be precise and to be kind of concise. And what cloudless means is you get your compute, which is all the processing that happens. Every time you open your phone, you're doing processing. Every time you use an application, you're doing processing. Everything that happens, all happens in the centralized cloud. And what Fluence is doing is building a way and has built a way for that to happen outside of the large centralized carriers in an open way. So you're not dependent on any one of these big tech giants.
Now, with that, is the data that's running through, is it through a server? Is it a decentralized cloud infrastructure? What does that look like on the back end?
Yeah, so data needs to be processed in CPUs. And so this question really is just who owns those CPUs and where do they sit? And so right now, even most of blockchain nodes and blockchain applications, all the processing outside of kind of the smart contract DeFi world, all of those exist and run in the cloud. So they're running on Amazon servers. And so with Fluence, and what that means then is Amazon can shut you down. Amazon can raise prices. You want to leave Amazon, it's complicated and expensive. And so what Fluence does is create an open system where you can leave your provider when you want, and you also have your own data. And so that processing can happen at still very secure top tier data centers, but it's happening in an open platform so that you're not locked in to any one ecosystem.
Is it hard for a developer to move their data from a server like Amazon or Google onto your infrastructure?
It's easier to build it in the beginning. We are working on tools to make porting easier. And so our
transition, right.
Yeah, and our obviously the goal here is the one click, move so you can leave easily. We are not there yet. And that's a development which is coming. It sounds simple to have, an open ecosystem. The reality is there's lots of tooling, lots of application and use specific software that needs to be built, and an ecosystem has to be built to basically enable the same level of functionality you have in the cloud. But we've built the rails to do that. And we think that with the assistance of the open source developer community, we will accelerate the kind of tools on Fluence that will make that building much, much easier.
Now, when you talk about cloudless, the infrastructure itself, how is it decentralized? Are there nodes on your network? Where is the data stored? And is it stored in shards to where if one server within the network goes down, are you still going to be able to access your data?
So there's a couple different questions wrapped up there. And so first, right now we have, I think, 6 or 7 compute providers that are our launch partners. And so these are top tier data centers that are around the world, in the US, in Australia, in Europe, in Asia, and top tier data centers. And they provide the compute. Many of them actually, to your point on storage, are also storage providers for Filecoin. And so data, the idea here also is that your data can be, we don't deal with the storage. Fluence is not a storage protocol. We're just a computation, but you can plug in to Filecoin. And so your data can be stored with Filecoin or other decentralized storage protocols and networks as well.
What would be the biggest use case for decentralized computation then?
Well, I mean, listen, it can be anything where you want the data to be, your data to be resilient and not subject to a single point of failure, and where you really don't want to be subject to any particular either security issue or influence. And so you recently saw this Cloudflare Microsoft debacle, right? That
Yep.
took down, airline reservation systems. It took it down
All
globally,
around the
all around the
world.
world.
Yep.
And to me, there's a couple interesting things about that. One is that doesn't happen more often because presumably, you're at that risk. So that is actually amazingly that it doesn't happen more often. But the second point is that is due to homogeneity largely of software and hardware, right? And so everyone was subject to that Cloudflare update, and that knocked out a massive amount of infrastructure. And so if you have a decentralized network and you think about the Fluence network, we have these 6 different providers right now that will get to dozens and hundreds eventually. You're running different hardware, they're running different software, you're running it kind of globally. And so you're far less subject to a one software update vulnerability, the way you see
One
this.
point of failure.
Yeah,
Yep.
exactly. And so that is, I think, important. But also backing up in terms of decentralization, there is a view that you're not decentralized unless you have X number of either hosts, nodes, governors, whatever it is. I think you actually go back to decentralization. I take it the other way, which as long as you don't have one entity which is
Controlling multiple. Yep.
then if you don't have one entity controlling it, then you are decentralized. Now you're more decentralized if you have 5 or 10, but you don't need to get to 1,000 in order to be decentralized. You just need to have not one entity which is controlling it all. Exactly. And so that's how we approach it, and that's why we want to make sure we launched with a number of different compute providers. And by the way, in our governance system, which gets to decentralization as well, is on chain. And so the compute, this is an important piece here. The compute is off chain. It's regular CPUs, right? Just like it happens in 99% of the world.
Right.
But the governance is token voting on chain via a Swiss, a DAO, which is based in Switzerland. And so that DAO controls this all. So it's decentralized certainly from a governance perspective easily.
Now with the DAO itself in the voting, what types of things would they be voting on for the network itself?
I mean, everything. The current vote right now actually is to enter into a software services agreement with Cloudless Labs, which is the development of the protocol. So Cloudless Labs is what raised the money. Then the DAO spun out, launched the network, and has the IP. Cloudless Labs now has to enter into a software services agreement with DAO with Cloudless Labs in order to continue development services. And so what we think will happen is other groups will come up and say, hey, we want to develop this part. Can we have a grant to do this? So the DAO will issue or not issue, approve, not approve that grant proposal. Other people may say, we have a grant, we would like to market X, Y, or Z, and then the DAO can decide to do that. The DAO can also decide to take the network in a different way and vote on technical changes, updates, etc.
Now, circling back to the original point, what types of businesses, projects, or applications do you see using the Fluence infrastructure?
I think there's 2 initial areas that we think are interesting. One is actually running the blockchain nodes, and a whole lot of most blockchain node infrastructure actually runs in the centralized cloud. And that is
100%.
right.
Yep.
And that is a real, disconnect given the decentralization objective and ethos of the industry. And it happens that way only because there haven't been really scalable alternatives to the cloud up till now. And so we think that we are now in a position to begin to run a lot of the blockchain nodes on Fluence. And so that's one that we're very excited about because it would effectively help the industry decentralize, which we're happy about.
Right.
And then another area.
That's let me stop you there a second. So over the last few years, that's a thing I've noticed with a variety of different main chain products is when a project launches and they need that infrastructure for hosting their nodes, they either partner with one or two providers and then they pitch that to the community, and most of the community is running off them two different server farms. And I thought in the back of my head that wasn't the most safe route for them to go by running all of the nodes on them two centralized infrastructures. So you're saying that Fluence has the ability to be an alternative to something like that?
Correct. And there's two different ways that we're an alternative to. One, there's certain groups that run that infrastructure in-house, right? They run it themselves. And that is probably not the most secure, most resilient way to do it. The other is you can run it on the centralized cloud, which is definitely more resilient and secure than running it yourself, but you're subject to all kinds of other centralization risks and lock-in and, a whole number of things we sort of talked about. So we are an alternative to doing it either of those two ways. And if you even take a step back further, you realize this is kind of a window into the whole evolution of compute, where people and companies started doing everything in-house, right? Everything was servers in-house. And then eventually the cloud came along and people moved to the cloud. They moved to the cloud because it was cheaper, it was more secure. No one wanted to run the servers themselves because it wasn't their core business, right? And so let's get to people with their core business. And that makes sense. But these massive margins there don't come from nowhere. They come because they're monetizing this expertise. And so Fluence, we think, is the next generation where it then moves into a decentralized network where it's far cheaper, far more resilient, and is ultimately a better way to do it versus running it in the centralized infrastructure. So we view this in sort of along the path of where computation has come from, being in-house to cloud to decentralized. And I think that path you will see happen across lots of sectors besides compute, but compute's kind of the easiest one to chart given where we are.
What do you think the pricing looks like for the difference in using Fluence versus a centralized provider? You mentioned the price a second ago. Do you have any specifics on the price or a percentage of decrease by going decentralized?
We think the pricing is between 60 and 80% less than the cloud.
Wow.
And the reason for that is that when you can switch your provider easily, costlessly, right, you eliminate pricing power. And so, right. So and that's why one of the reasons why these clouds have high prices is not so easy to switch. And so if I can switch from one to the next in any sector, right, across any economy, then you commoditize whatever that is, right? And so that's what our objective here is you commoditize this compute and you allow people to move. And when they can move easily and seamlessly, it doesn't give an opportunity for providers to have high margins, which means prices fall. Now, we fully think that's the case. There's some
flood in the market.
Yeah. And then the lowest cost is where compute goes to, right? And so, right. And that's that. And then they may want to sell other services on top of it. They may be loss leading. And there's all kinds of different business models in there. But when you can leave like this, that means there's no pricing power. And so there's some nuances to this. And there's, again, more software tooling we have to talk about. But that's the rationale for why pricing will be lower. The only question is how much. And we think it's high. And we also think that it's not a threat to the clouds yet because we're insignificant. And so it doesn't matter. And so they're not going to hit their margins by worrying about someone that's, aspirationally getting millions or tens of millions of whatever it is of dollars of revenue. So I think we have a real long path before clouds start to really worry about it.
Okay. So it's something that's it's going to take time to reach where your competition is right now. You guys are building infrastructure that is brand new to the world at this point. So it's going to take time to build up and compete with Amazon Cloud and things like that.
Yes, it will. But that's also why we talk in very specific, narrow use cases like blockchain nodes. The other is maybe AI data cleaning called data pipelines, where you're actually standardizing the data before it goes into AI models. And that's computation that also we think is suitable for what we're doing. So if you start with very specific use cases, you can expand from those over time. And that is our objective. We're not trying to, track all the tooling and all the use cases of the cloud. That is that's not something us or any team is really set up to do right now.
But by looking at it like that, the developers have an option. If they're building a product today, they can go with a lower cost basis by going with Fluence versus Amazon Cloud for their product if they were to start a new project today.
Yes, that is definitely true. You can definitely. Now, there's also pieces there, though, you have to think about it a little carefully, because the cloud is obviously these companies are bright, and what they will do is give you free credits. And so so if you actually have to think about this a little bit, it's actually free to start on Amazon and Google. So we're not cheaper than free. And so you have to kind of forecast out.
But then 6 months or a year down the road, and they're going to hit you with a 10x on that price.
Right. And
so
sure. Exactly. It depends on the scale and where you want to go and where you think you're going to go. So that is the thing to be thinking about.
Now, as far as the Fluence DAO and the infrastructure for this cloudless platform, how does cryptography and blockchain play a role?
So we are off-chain compute. And so that means that compute happens just like it does in typical data centers on CPUs. This is not an on-chain computation. We do that because we think consensus overhead slows things down. And so there's certain use cases like DeFi where there's lots of money involved. You want consensus overhead, you need it, and that's fine, and that's great. And we think that is the obvious path. For standard computation, we think that's not necessary. So we use blockchain to validate, verify, and reward. And so we use blockchain for kind of its specific attributes. And so, for example, when you are a compute provider, you or an investor will stake in order to prove trust. And so if that computation isn't performed or you stop performing it, your stake will be slashed. And so that is a way that we use, crypto in order to provide trust, so that you actually, users and customers, can have faith and comfort and trust that the actual computation will happen, and they can rely on the providers. That's kind of the main way.
Do end users have to run nodes or anything, or is it just the token for staking?
Not at all. That is it. And then frankly, they don't even need to use the Fluence token to pay. We want this to be as open and easily usable as possible. And so it's really, we think, stablecoin oriented is where 99% of the value will be transacted in. So it's not even our coin, again, because we want to drive use for it. And we also are building a fiat front end. So we think customers won't even touch the token when they use Fluence,
unless they're participating in the governance.
or are an investor who wants to stake in it and wants to kind of help provide trust by staking in it as well. But we do not think that. We think that making it easy to use is kind of a very I think that's been missing in the whole blockchain infrastructure overall. And so any barrier we can eliminate to do so, we would like to do.
Do you see any application for AI to run through Fluence in the future?
We think there's two ways to do it. So first, there's the AI kind of adjacent use cases, such as the cleaning of data I mentioned before, for which CPUs are useful. That's fine. The other one, though, is that a lot of the infrastructure and a lot of the tooling we've built is built for CPUs, but is also applicable to GPUs, obviously used for AI data model training. And so we are looking at potentially adding GPU support to the network as well. And if we do that, then Fluence would be available for as a GPU marketplace, effectively GPU platform for people to secure compute. And I think one of the important parts about Fluence is that as capacity is added, providers are paid in the Fluence token until there is customers who are paying them in fiat or stablecoin or whatever it is. And so if you join the network, your resources do not sit, you don't just sit there and wait for something, you're actually being compensated. And the way we've set it up is that you're paid in a dollar equivalent. So effectively you're paid in the FLT, but there is we target $10 per core per month. And so it's not as if it's just a random amount of tokens you're paid. And so we think that is also, we wanted to make sure that providers have some level of certainty that their costs can be covered. And that is, I think, very important as well, because there's a lot of ecosystems where there's just an arbitrary number of payments made that relies on some price. And that is, I think, a hard thing to really attract infrastructure that will endure for a long period of time.
To circle back on the AI aspect, I was just thinking about centralization or the data itself being altered in a cloud infrastructure versus a decentralized infrastructure. Is that more something on the front end for a developer, or is that something that could be a vulnerability in the back end for training these AI models?
Yeah, I mean, I think there's, I guess, a couple different verification levels you want to do. First, you want to verify that the model was trained on specific data, right? So first, what data was used? Was a model trained on this data? And can you verify that? And that is verifiable. So that's sort of point one. And then point two, you want to make sure that your query was executed against the model without interference and without manipulation. And you think about this, for example, with the Google Gemini, where there's clearly manipulation in that model that they took it offline
before it comes back,
right? Yeah. And they built all these rules in so that it would return a result that was more philosophically, culturally, politically aligned with their vision, right? And so they could say, hey, we trained on this data, but then you actually ran the model with this other stuff in it, right? So you have to have both of those two things verified. And that's actually why we think that open source and open verifiable models will ultimately be the most trusted models out there. And if you get even further to this Meta model, which was released, and there's big fanfare because it's open source, and that is a big step forward, and that's terrific. What's not open is the data in which it was trained. So we don't know the data on which it was trained. So great, it's open source. Great, you can adjust the weights. Great, you can see the weights. That is awesome. So we're very happy. But you also need to know the data was trained on. I suspect they're not releasing that because of a whole number of gray areas with regard to the provenance and ownership of data. And so, that becomes another thorny issue.
That was the thing I seen today was a big YouTuber. He made a video about one of these AI models being trained off his data from his videos. And he said he never gave him permission. So that's another thing you have to look at when these AI models are collecting data sets. Like you said, if Meta's not releasing that, what it was trained on, there's either stipulations in the coding itself to where it doesn't kick out certain results, or because of what it was trained on, the different uses that may not have been given permission to use to train that model. So there's a bunch of different angles to why a company would not release that information.
Correct. Totally right. And I think that's also why we will see models in the future that prove that their data this particular data was used, and they either have licensed that data or it's proprietary. And then you go back and you think about, this XAI, right? Elon's AI model, which will clearly be using Twitter data, and Twitter is now potentially investing in that, right? So they will be very sort of theoretically clean with regard to the data, because you'll probably sign something, or you maybe already do when you use Twitter, that your data can be
Yeah.
used for a model,
That's scrapped.
right?
Yeah.
And so that is, I think you will probably see models run on proprietary data sets that are validated and verified. And we think even further about this. Think about like a children's cancer specific model that only uses data from 3 or 4 of the top hospitals, pick it in the US, whatever. So now you've got a model that is provably using only that data, licensed from those institutions, maybe prior to those institutions, I don't know, but that should be pretty trusted versus something that's not. And so, you start to see, and then that's very specific. So then probably you aggregate that model and have a front end that aggregates that model versus a number of others. And so I think that's sort of a path that this could go down.
Okay. Yeah, because I think about the different data sets that have trained OpenAI. And when you go from that data set that it was originally built on to the results it's kicking out, I've noticed just in the last couple weeks, I do random search queries and it kicks me back with, I'm sorry, I'm unable to give you a response or create an image based on your input. And that just blows my mind that the amount of limitations that are being put on this type of technology already. Now, I wasn't looking up anything crazy. I'm a regular person. But for me as a business owner to have to find alternatives to find the information I'm trying to research, I mean, you throw a wrench in the whole philosophy of using AI.
Well, yeah. I mean, listen. I violently agree with you, and I guess the problem that these companies are going to face is as AI grows in importance, it becomes viewed as a source of truth. And if it's viewed as a source of truth, who cares about that? Governments care about that. Shareholders care about that. Activists care about that. So all these companies, all these CEOs, all their boards of directors are all going inevitably to be subject to all kinds of different pressures, right? They're not just one, it's different pressures.
Yeah.
And that's all going to come down. And a result comes back that some group doesn't like, they're going to freak out. All right. And it could be in any topic. And so that's right. That's super tough. And so, and these are people who don't want people picketing outside their houses. They don't want to have pies thrown in their faces, right? They don't want this stuff to happen. So you have a tough time seeing how these corporate models are not really subject to some pretty tight constraints in a lot of topics, which means that you end up with these open models, which are decentralized, for whom there's no one to go get, target, influence, that end up being much more real with regard to what they answer. Now, there may be some negative associated with that too. It's not all positive, but there's going to be a very big difference between the answers that some of these open, completely decentralized models give versus the corporate controlled ones.
Now, another thing I think about, and I don't know how much it plays a factor in the overall of AI, but you think freedom of speech, and how does freedom of speech play a role in what the AI kicks back to you, the information that you receive? If it's being censored, do you really have freedom of speech?
Well, that is a harder one because it is a harder one because there's no freedom of speech means you can say what you want without consequence. Doesn't mean someone has to tell you what you want. Doesn't mean someone has to give you the answer you want.
That's a good one. Yeah.
Right. So if you're not allowed to say something, that's one thing. But if you're asking a private company for something and they choose not to answer or choose not to give it, that's their, prerogative. Now, if the government has forced them to do something, now you start to enter into this area. And that's where you get this whole gray zone of, did the government influence Twitter around COVID and everything else? Was that legitimate? Was it not? And so we've seen courts kind of go back and forth on that a little bit. So I think the ability to say something is one. The ability to demand an answer you think you deserve is another, and so that gets a little harder.
Right.
But where it does,
and that makes sense because they don't stop you from your input.
right, exactly,
You can input anything you want,
correct.
but they might not kick you back an answer.
Where this gets interesting is what is freedom of speech with regard to trying to shut down or censor an open source model. That gets really complicated because imagine there's just an open decentralized model, right? And now does that have the ability to operate without consequence? And that is a harder one. I don't think we've seen that really addressed yet.
Right. So moving on from that, what other uses do you see for Fluence? Are there any communication models that you could see being built on top of this infrastructure?
I think that this, as we mentioned, this AI area is obviously huge. It's not going away. I'm excited about the large number of computation intensive stuff that happens that's also price sensitive and or episodic. So think about pharmaceutical analysis for drugs where you've got massive data sets. The computation takes place over weeks, but it doesn't have to happen in a moment, right? And so you can then have an open system where
running in the background,
and it's like, okay, there's no demand for XYZ data centers CPUs now, so they drop their price, boom, it gets used, right? I think that is very interesting. And then the other point here is the serverless area, which is where Fluence is also serverless side, which is where you don't rent a particular server, right? Serverless means you are renting compute by the operation. And so as the whole world becomes more episodic, less predictable, and spiky in terms of attention, and attention effectively is computation to one extent or another, you end up with more and more need for immediately scalable and descalable computation. And so I think about the demands at a football match or an F1 race, right? Shoots up, goes down, and that's everything from the cars to the data processing of the TVs to the attendance to like everything around every element of those. And I think you will see that is the other area I'm excited about, where you can run that type of computation decentralized, serverless, so you're always being able to operate kind of the most cost-effective way to do it.
I was thinking more when I said communication systems, I was thinking more something similar to Telegram, but on a decentralized infrastructure to where there would be no shutting down those communication angles. Is there any possibility for something like Telegram to be built on top of this infrastructure to where the information couldn't be altered?
For sure, there is. But there, I guess, I don't know how to phrase this the right way. So you certainly could. And one of the first things we did at Fluence was we built a decentralized chat app as a test case. We built it live in like 15 minutes in 2 years ago. So that's certainly possible, but those also do not require a massive amount of computation. And there are other mechanisms for doing that as well, peer-to-peer, where you jump phone to phone to phone to phone. So there's other paths for that type of thing to happen.
Options to where it's not an emphasis at this point.
And the problem with those also is that you can build the best one in the world. You got to have the users, and it's the network effect, right? And so without people using it, no one else uses it, right? And so it's just building it is not sufficient. Right. You have to figure out what the path is for adoption. And that is that's a big challenge. And that's not something, and someone certainly could do that on Fluence. That's not something we've emphasized just because it's beyond the scope of our expertise to figure out how to scale one of those applications.
A communication system.
Exactly.
Right. Now, as far as the data behind that, if say you had 50 million users using an application like that on top of Fluence, is that the type of data you could see influx and reduce over time?
The type of data you could see. I'm not sure I understand the question.
Well, maybe let me rephrase that. You mentioned a moment ago of the influx and then the decline, the spikes.
Oh, the spikes. Yes. Yes. I mean, yes, to the extent there were surges in activity.
Users sending messages or files and things like that.
Yeah, I mean that's something that Fluence certainly has the ability to, and the providers that are underpinning Fluence have the ability to respond to and accommodate. Yes.
Okay. Now let's circle back to the biotech aspect. You mentioned that there is the possibility for biotech data processing within the ecosystem. Is anybody specifically building a product using that, or is that something you guys are building yourselves?
No, neither one, to be fair. That is just a use case that I'm kind of know is a large one out there. So we're not there yet with that at all. And there's other additional tooling required in order for that to become an executed use. We just are, I spent a bunch of time with different pharmaceutical companies when I was part of Hedera Hashgraph, which is kind of a layer one that I kind of helped found. And that just got me familiar with the amount of data computation and kind of the needs those companies have in this space. And so I'm also aware it's a big cloud use case as well. So I'm sort of very aware of it. We are not yet mature enough to be able to attack those uses yet. That's just something that I am very kind of targeting in terms of how we think about
envision for the long term,
how we think about our infrastructure and what it's applicable for and how that could be useful.
Okay. Now, when you look at that as a whole, what types of use cases could you see for biotech with In-Fluence?
I think, with it, there's clearly data.
Would it be hospitals? Would it be providers, doctors?
I think it's largely, the biggest one would be data analysis, and data analysis can happen from the pharmaceutical companies by and large. That's the most obvious place. And hospitals have lots of data to analyze as well. But I think those infrastructures are much harder to crack from a customer perspective, and they are much more entrenched with their current providers. And I think that is a less of an opportunity. And you also have, with hospital patient data, you have a whole regulation kind of network to go through with regard to being HIPAA compliant, which is also a whole nother sort of expertise and difficulty. So I think that's probably not anytime in the foreseeable future, but a data analysis is certainly.
Could colleges, I just thought about that, could colleges use this type of infrastructure to do their research?
Yeah, for sure. And you think about their big universities, some of whom I think I'm blanking on the name, but one of them was an early user of Filecoin in terms of storing data. And so universities certainly have large research departments that have both data storage and data analysis needs, and are also, price sensitive. And so that is certainly something that would be a great customer base, without a doubt.
Yeah, I think about that. That'd be crazy if you had 5 different colleges teaming up from different parts around the world, and they're all researching the same subject, but they're coming up with different results based on that data that would be in a decentralized cloud infrastructure. Could you see something like that to where the data sets could be transferable?
For sure. I mean, they could permission that without a doubt. That could, I mean, what you're effectively talking about is open source data sets where the data is stored in a decentralized network, or even it doesn't even have to be decentralized. It could be stored in a centralized network, but with everyone, with multiple people or groups or unlimited having access to it. And then you could perform that computation. Different computation could be performed on those data sets for sure.
So many different use cases for this technology. Now, I want to circle back. You just mentioned that you were part of the founding team for Hedera. That blows my mind. Could you speak on that a little bit and how you transitioned into helping create Fluence at this point?
Yeah, listen, I joined Manson Lehman when the other two co-founders, when it was just a white paper. And so it was just called Hashgraph. And so we collectively created the Hedera, the public ledger, from, the governing council to, help. I got the governing council and I raised the initial money, hired a bunch of the team. So was really, that was my first entry into blockchain and crypto. And that was, and I think late 16 or early 2017, I think is when it was. And so that was an intense period, but a great way to learn and to get involved. And I left in 2019 and was introduced by one of our investors to the Fluence team and said, these guys are really the top technical team I've seen. And you would be a great partner with them. So I joined as a co-founder in 2019 after I had left Hedera. And I liked it because, right, it's also not a competitor. It's not a layer one. We're doing compute, which is off chain. So it's a very big problem that we're solving, but it's also not a layer one. And so that was also interesting. And the other point is that the Fluence team is very crypto native, very deep in the ecosystems. And so that was something I felt was a very important to have after the Hedera team, where all of us, myself included, were not crypto native in the beginning. And I think if we had more crypto nativity, we would have made some better choices and would have been, a bit more, a bit more aligned with the overall crypto ecosystem, because I think Hedera does not get the credit that it deserves for the terrific technology and execution that it has delivered. And I think a lot of that is just narrative and relationships.
The wording, yep. Yeah, that's what I've noticed with it.
No doubt. So
for sure. So to close out the interview, I just want to say thank you for your time. I appreciate you being here. Is there anything else you'd like to add that you don't think we've covered in this episode?
No, I think, listen, I appreciate it. I think the questions are great. We've dug deep into Fluence. And I guess the only thing I'd say is that decentralized compute is very important. We have decentralized payments with our Bitcoin, Ethereum, as we all know. Decentralized storage is like a Filecoin. There's others. But without decentralized compute, we are all using the cloud. And that is a dangerous place to be in multiple categories. And so whether it's Fluence or it's a different project, I think we all need decentralized compute to work in order effectively to remain free. And so we really need decentralized compute. And so I would just say that is I view that as a very important mission for us and for everyone in this ecosystem to be thinking about how to participate, how to help build. But get in touch with Fluence, Fluence_project on Twitter or X is probably the easiest way. I'm at the Tom Tro on Twitter and X. So definitely check us out when you can.
Decentralized compute is our freedom call. Thank you for being here, Tom. I appreciate your time, buddy.
Great. Thank you, Joshua.
The Crypto News Podcast with your host, Joshua Roomsberg. Follow and subscribe today